Hey everybody, welcome back to AP Stats. We're starting to wrap up Chapter 2, How to Practice Statistics, and that's the end of the first unit that College Board gives us, all about one variable displays and stuff. And so we've got 2 more units to go through after this, if I remember correctly. And then test time. Yeah. Anyway, copies of these notes, remember, below. There's a link below if you're in my class. I've posted them in Classroom or on the module doc. Like, comment, subscribe, whatever you would normally do on YouTube. As you can see, I'm playing around with a little bit of overlays because I figured seeing this table is not necessarily the most exciting thing, and at least it kind of breaks things up a little bit. Plus, I like learning new stuff because everybody needs a side hustle, right? Anyway, let's jump in. We're going to be playing with Back to the Future today. So will Marty make it back to the future? After accelerating for 20 seconds, a DeLorean sports car has a wide range of speeds that it can achieve. Depending on the traction, distribution of speeds follows approximately a normal curve. Hey, look, it's a normal curve with a mean of 80 miles per hour and a standard curve of 7.7. So label the opposite values or the appropriate values on the normal distribution. So here's my first, there's my mean. It's always in the center, remember. So I'm going to label that 80 miles an hour. For every standard deviation to the right, which is above the mean, I'm going to add 7.7. So that's going to be 87.7. 95.4, and then that's going to be what, 103.1. Excuse me 1 second. Need to give myself a little bit more room. There we go. Okay. Same thing on the left side, except that we're going to be subtracting things then. So when we subtract 7.7 off, I'm going to end up with 82.3, excuse me, 72.3. Sorry for the pause. I thought I had whiteout. Apparently I don't. I left it at school. So anyway, 72.3. And then we subtract another 7.7 off, and then we're going to come up with 64.6. And then 56.9. Okay. Ta-da. Great. So what do we do with that? That's probably the bigger question. What percentage of runs will, what percentage of the runs will, stop it. What percentage of the runs will give the DeLorean speed a greater of 87.7? Okay, a couple different ways you can do that. One thing that the AP Stats teachers will tell you is that you should probably draw a little picture. Why? Because in that way you can kind of get a sense of where things are going. So I've got, here's my 80, and you don't have to redraw this whole thing. Just draw enough so you know where you're going. Think, and don't worry, but don't think of it so much as work as think of it as a graphic organizer, because it's going to help you organize your thinking. If you write it down, then you don't have to remember it. Greater than 87.7, so I want all of this. Now the way that I remember there's a number of different ways you can do it. One way is, if you're thinking about this, you've got 68% here, right? Which means that I've got 100 and minus 68 in these two spots. So you're going to break those up. So that'd be 32 divided by 2, and I get 16%. That'd be one way to do it. Another way that I do it is I kind of think of it this way. This is 50% up to here. I know that this is half of 68, so then this would be 34. This would be 50. So then you could also do 100 minus 34 minus 50, and you'd still come up with 16%. Just so long as you can show the work, you'll be fine. Okay. What percentage of the runs will give the DeLorean speed between 64.6 miles per hour and 87.7 miles per hour? And again, so this is, again, we're just using that rule from yesterday, right? That's the 68, 95, 99.7 rule. So can we use that down here? Sure, because why? The 64.6 is here, 87. Those are standard deviations that we have. Consistency, Mr. Hayes, we'll draw in purple. So I've got one standard deviation there, and I've got 64.6 here. I have another one up over here is 87.7. And what do we want? We want this area in between. So how do we figure that out? whole bunch of different ways. Okay, you could say, hey, this is 68% here in the middle. How much is this over here? Well, remember, 2 standard deviations is 95, right? Now, if you remember from yesterday, if I had the sheets, hold on. You could look back at your notes here. So that's going to be 13.5, so I could just go 68 plus 13.5. So that would give us, what, 71, 81.5? And if you're one of those, if you need a calculator, go for it. The great thing about the stats test, well, I shouldn't say great thing. The thing about the stats test is you get to use a calculator. We give you a formula sheet, though they don't tell you what they're necessarily for. I mean, so it's so much about the interpretation of what's going on. So you could do it that way. Sometimes people will do this. They're like, okay, this point right here is half of 5. So I know that from here to here is going to be 47.5%. And then I've also got 34% here. So if I did 47.5% plus 34, you know, that would also give you 81.5%. So there's not one guaranteed way of doing it. So anyway, so a lot of various different ways that we can do that. What percentage will give the DeLorean a speed of less than 64.6 miles an hour? Again, draw yourself a pretty little picture. Wow, that's not pretty. I'm sorry you even had to see that. Too big. There, that kind of works. All right. And then we want what? Under 64.6. 64.6 is 2 standard deviations. 1, 2. So again, you know it's 95, right? So this is 95 through here. So that is going to equal, that means it's 5 percentage points for the rest of it. So that's going to be 2.5%. Okay, so again, lots of different ways you can do it. These are just some of them. Let's take a look at the bottom one. So what happens what percentage of the rent will happen less than 68.45 miles an hour? So you come back up here and you're like 68, wait a second. 68.45 would happen between these two. So you know that, much like this one, so this is going to have like 16% from here on. This is going to have 2.5%. We just figured that out. That's going to be 2.5%. So it's going to be more than 2.5%, but less than 16. But how do we figure out the exact value of it? Remember the thing that we learned a couple days ago? The thing called the Z-score? I know, right? Sorry, couldn't resist. So take a look at this. So if you have your Z-score, now again, remember, how do I find my Z-score? Z is equal to your value minus your mean over standard deviations. Because remember, Z-scores actually measure the number of standard deviations above or below the mean. So now it's like, cool. So let's go ahead and just keep on going with that. So I want 68.45. And then we're going to subtract off 80 and divide it through by 7.7. There's all our parts. Mr. Hayes, do I need to really write it all out? Yeah, actually you kind of do. If you don't write all of this stuff out, then you pretty much have to go through and label out value is this, mean is this, and just put it in the same spot. Okay, it's organizing yourself. And then you're going to go ahead and run this out. So again, do the math correctly. We know it's between, we know that this number, 68.45, is between 64.6 and 72.3 standard, So that means you're going to be between -1 and -2 standard deviations. If you type this into your calculator wrong, you will get a number about like 53. Okay, so do your order of operations. So otherwise I'll be all like, what are you doing? Bigger question. How do we turn this into a percentage? And I will give you a hint. It's not going to be halfway between 16. So from here on, we said was what? 16%. And from here on is 2.5%. Why isn't that going to be halfway in between? Is this uniform? No. So you're not going to, you can't average it because this is not a straight line. Well, here we go. First of all, let's remind ourselves this. Okay. The speed of 68.45 miles per hour is 1.5 standard deviations below the mean. Great. Then what? There is something called Table A. I got to fix this light. Shadows are casting it. What's Table A, you say? Well, let's see if I get this right. That's what I want. Switch over here. Boom. Z-score table. Actually, this wouldn't be bad, especially if you haven't gotten the book yet. This wouldn't be a bad thing necessarily to do it there. I'll show you how to do this on your calculator eventually, but some people actually, I had probably about a third of my students last year actually just prefer to rather use Table A. So what you're going to do here is this. Let me point out a couple of things. So here's your Z-score. Up here is Z. So this first column is up to the 10th place. That's the 1 decimal point for those of you guys playing along at home of the Z-score. So for 1.5, I go down here for negative 1.5. Now, the question is, what do I do with these other columns? This is 1.50. This would be 1.51. So this is the 100th place falling in. So you go down for the first 2 digits of your number down here, and then you go for the third digit, second decimal place over here. So for 1.50, we get this number right here of 0.0668. Okay. So then when we come back here, okay, so your area under the curve then is going to be that, which then would translate out to become 6.68%. Now notice again, like I said, it's not exactly halfway between 2.5 and 16%. Part of that's, and so what would that be? That'd be like 9-ish. It's a little bit less because of the curve. We're getting steeper as we go up, but that's fine. Okay. And you'll be given actually a copy of the Z-table on the test too. So you'll always be able to just kind of pop back, and if you need to see this, okay, I just put the kid up, didn't I? That's what I want. You guys deserve so much better of a YouTuber for a teacher. So, anyway, there's that. Okay? Let's try one more. And you would actually have to say, you'd have to read it. You're saying on table A, it says that, just kind of like what we did. Okay? So we're going to go through number 6 here. And we're going to talk about what you need to do on a problem like this to get full credit. My camera keeps, I don't know why my camera keeps moving. My upper bound. Wow, I am just. Mr. Hayes, hit pause next time. Thanks. Will do. All right, so what percentage of the runs will give the DeLorean a speed of greater than 85%? So again, same idea. So first of all, we're going to draw off the picture. Okay, and this is going to be the unstandardized, is it? Yeah. So I've got my 80 here, I've got my 85 here, and then I've got this going that way. Yay! Benefit of that, then we know that we have to go larger than that, okay? So, for example, now we'll talk about that later. And then what we're going to do here, oh, before I forget, notation. Back here. When you draw a normal curve, first of all, you have to declare it's normal. It's just not good enough to say, oh, it looks like a normal curve. Nope, doesn't matter. So we're going to declare that it is normal. And then behind it, in parentheses, the 2 things that you write down is you're going to write down the mean and you're going to write down the standard deviation. Always, always, always. Twice on Sundays. So when we draw this over here, we're going to put down our little normal curve. Make sure we're seeing there. So I'm going to say normal. And what that does is it allows everybody to know what measurements that you're using. Okay. So from there, we're going to go ahead and figure out the z-score. So we're going to say z is equal to 85 minus 80 divided by 7.7. So that's going to end up, when you do all that math, you're going to get 5 over 7.5, so it's 0.65. Ta-da. Now, we do want you to go through and you're going to do a standardized version of this. Why? Because that would allow you to say that you understand that there's the connection between the two, and then it will also allow you to use your calculator or table A. But Mr. Hayes, we didn't do it on the other one. Yeah, we didn't do it on the other one because we were just kind of figuring out how things work. So remember, on a normal curve that's standardized, your mean is always going to be 0, and your standard deviation is going to be 1. 0. Here, I'm going to use my z-score of 0.65, and we're going to shade to the right. Not earth-shattering. That's okay. So for table A, what we're going to end up doing here is this. Now, table A is always going to give you area to the left. Okay. In fact, I think the picture's up here. Okay. Find the values on the left. Blah 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 blah. Great. Now we're doing a positive one, so we're going to go scroll all the way down here to the positive one. So when we look for 0.65, which is right here, so 0.7422, notice, and again, the way I'm doing that is 0.65, and then I'm going to go over, so this is 6.60, 6.1, 6.2, 6.3, 6.4, 6.5. That is all the area from your z-score to the left. We want, and this is the whole reason why you draw this picture over here, we want the area to the right. Okay? So just making sure I've got the right one on. I need a second monitor to really get this clear. But anyway, it doesn't matter. So we want an area of 0.6. Okay, so it's 0.742. So we're going to do, oops, more than you need to see. Switch. There we go. All right. So since, what do you say, Mr. Hayes, you're supposed to be keep remembering all this stuff, 7422. So this side over here is 0.7422. Which means that from table A, my area is going to end up being then 1 minus 0.7422. Why is it 1? Well, remember back from, what was it, yesterday, what's the area always going to be? 1. That's why I even had you write it down in your notebook. I know. It's almost like we know what we're doing. So when you do this, you're going to end up getting, what, 0.26... No, 478. So 24.78%. So again, now what do we do here? Okay, so for full credit. One, you need the unstandardized picture. With the label and shading. Picture, label, shading. Okay. You can then, kind of do, I think I did these out of order, didn't I? So then I did z-score with your formula. No formula, not full credit. 3, standardized picture. Some people would say to switch this. The reason why I'm saying it this way is that you can't label this one down. I mean, I suppose you could just do it and then just add it in later, and that's fine. I kind of like getting this part done first. And then last but not least, your final answer. Okay, is that my final answer? You should probably write it out. Okay, so much like what we did before. For sake of space, I'm not going to worry about that. Now, to do this on your calculator, what you're going to end up doing, and so this would be how you would end up, instead of using table A, you'd use your calculator. You would have to write this part down. So you're going to go on your calculator, clear it out. You're going to see right over here is distribution. So I'm going to hit second and distribution. And you're going to say there's two normals. Why would we use those? Because we're on a normal curve. PDF is just at one particular point, and we're going to talk more about this in a little bit, but the CDF is the one that we want because it's cumulative. We want everything from this side over here. So we're going to pick that one. So for calculator, we're going to say, you would write down, I'm using normal CDF. So I'm going to choose that, number 2. Your lower end, what's the lower end of the shaded area? Okay, so 0.65. How far does this go? Infinite, right? So we're going to put in a very, very nice large number. Standard deviation, oops, sorry. I'm going to put in a very large number for my upper bound. Just makes it easier. Mean is 0, 1 is there, so big number, and then mean of 0 and 1. Paste again, boom, there you go. Now notice, this is a little different than what we have down here. Okay, and that's going to happen. It's not always going to be perfect, but it will kind of get you at least close enough to where things are going to be. And part of that's a rounding thing, et cetera, et cetera. If you wanted to, you could potentially do quit. The question I always get then is, can you type it in with the actual numbers? Yeah, you could. So I could type in 80, and I could type in a billion, and then I'm going to say, oops, I'm sorry, that should be 85. My mean is 80. Standard deviation is 7.7. Now again, not quite the same because I have a different number up on top. So, but it's close enough for government work. So you could do that. But either way, you do need to write down what you did. And the other thing that you're going to have to do is that you would have to say what each of these are. So you would then have to come back and you would say, okay, this is your z-score, or your value. This is the lower bounds. This is the upper bound. And then this is your mean. And then this is going to be your standard deviation. Okay? So what I want you to do right now, because we're coming up on 20, wow, that's a long video. Take a look at these two using this as a model, run through it, and then we'll come back to it. Okay? See you in a minute. Hey, welcome back. So, what percentages fall between 70 and 90? So again, picture number 1. There's 80, 70, 95. So it's going from 70 and you're going up to 95. So I know I'm going to get all of that. Oop, I forgot this. Normal. Now I'm going to get 80 and 70. Oops, 80 and 7.7. So I'm going to go 0. We need to figure out what both of these numbers are. Okay? So if you're going to do 2 z-scores in this one. Again, you need to write this out. So we're going to say z is value minus mean divided by standard deviation. So for the first one, I'm going to go 95 minus 80 divided by 7.7. If I do the math with that, I get a 1.95. So that'd be down here. And again, we know that these are here. Then I've got the other one. I'm going to go 70 minus 80 divided by 7.7. And when you do that, you end up with a negative 1.30. So then we need 2 areas, right? So if I do table A, the first one is going to be, so the bigger area here, so that's going to be area, and then I need this area here. So we're going to end up actually finding 2 areas and subtracting them out. So let's go over. So for the first one, 1.95, since I'm down here in the positive ones, I want 1.95, Actually, I'll put it down here on the list down there. 1.9, I'm going to go over to 0.5. 97.44, so that's going to be 0.9744 for an area. Minus, now for the other one, I need a negative 1.3. Put that up at the top, 1.30, so that's right there. So that's going to be 0.0968. Okay, now I've already written it down here. So for by table A, now notice we don't have any ones because we're not doing the whole thing. So then you would subtract those two numbers out and you would get 87.76. So 87.76%. If you did this for calculator, you would say, okay, let's get a little bit more stuff up here. So we did normal CDF of, let's do, we started the bottom value, the lower bound is 1.3, the upper bound is 1.95, 0, 1. And so you type all of that in. So you don't have to worry about any really large numbers in that case, which is kind of nice. Let's see how accurate this is. So 8.776. So much better, much closer. So that'd be worth it. For the second one, he wants, ooh. I think this deserves this. I know, what do we do, right? We want the last run to be the top 15%. Well, let's draw what that picture would look like. Now, since it's the top 15%, we know that the mean here, ooh, I forgot to do this. I'm sorry. I know some of you guys are yelling out. Your teachers are probably yelling at me for sure. So you got 80 here. Now, we know that this is 50% over here. So we know that there's some point over here where I've got the shading there that has an area of 0.15. Okay? Again, normal curve, 80, and then 7.7. Now, here's the cool part. So if we're coming back here, so we got 0. How do I figure out what that z-score is? How do I figure out where that goes? How do I know what's going on? Easy. So if you go back to table A, switch, okay? I want 15%. So if I want 15%, I'm sorry, here, let's go back here quick. If this is 15%, how much is on this side? That's going to be 85%. Okay, so on table A, look up a number approximately to 0.8500. Okay, so now if we go back, so I'm going to look for 0.8500, because that's the area to the left. 15% to the right is 85% to the left. So you're going to look through these lists, and you're going to look for 85s or a number close. Okay, there's 85.08, and this is 84.85. Which one of these is closer to 85%? It's this one right here. So that number is going to be 1.0. I'm going to go up here and get 4. Okay. Oops, forgot to switch. There we go. Okay. That gives you a z-score of 1.04. And that's what you're going to end up using. So I know that this is going to give me 1.04 if my normal curve has a mean of 1 and a standard deviation of, or mean of 0 and standard deviation of 1. So once I know that, remember, z-score is value minus mean divided by standard deviations, right? So my z-score is 1.04. I don't know what my value is. So that's going to be x. I do know what my mean is. My mean is 80, and I do know that I've got 7.7 as my standard deviation. At that point, it's algebra. Multiply both sides through by 7.7. Subtract off 80, or add 80 to both sides, and you're going to end up with 88 miles an hour. Great Scott! If you want to do this on the calculator, it's a little different. What you're going to end up doing here is that there's another button here called, it's again under distribution, it's called inverse norm. Why inverse? Because you're undoing what we're doing. So you do inverse norm. So this is for calculator. Inverse norm. And then you're going to put down what you want. I want 85%. And this one you have to do the area to the left. Okay. And then you're going to put in your mean and your standard deviation. Okay, so this is area, this is mean, this is standard deviation. And then if I hit all of those, what do we get? Area, 0.85. Ooh, I forgot. On the updated pluses, you can actually say to the left, so I'll show you how to do that. So my apologies. So the tail is going to the left. So if I hit paste, depending on which versions of the 84s you'll have, you'll get that. So you get 87.98, so 88. Now, why is it not the same? Remember, we had to pick the number that was closer to the 2. You could also do this way. So if you've got the more bigger, or if you got one of these newer ones, you would actually say I want 15%, and I want it to go to the right. Paste, you get the same number. Okay? So that's the done with part 1. 30 minutes of more fun than you can possibly imagine. So we're going to take a break here, click over to part 2, my class, put it in the notebook, and make sure you like, subscribe, everything else I'm missing. Talk to you soon.